Hello everyone. Happy Diwali and welcome to the Anxious Dev. Today we'll be talking about recursion, base case in recursion, as well as we'll have a code demo for the same. So yeah, let's talk about recursion now. Simply put, recursion means a function calling itself. You might be thinking that what does it mean, a function calling itself? And trust me, you will know when you see the code demo. So it is basically you have a bigger problem and you keep breaking it into simple, small problems till you get the most smallest problem for which you know the solution. Okay, and this function calling itself has to stop at some point, and the point at which a function stops calling itself is called a base case. So basically, give you an example. Okay, suppose you want to find a factorial of a number. In mathematics, we know that a factorial of a number is uh, the number minus one factorial into number itself. For example, if you find 5 factorial, it is essentially 5 into 4 factorial, right? So here we can use recursion. I have put it on the screen as well. So factorial n is basically n into factorial n minus 1. Okay. So here we can break the problem of finding factorial into smaller problems, right? And we know that factorial of 0 is essentially 1. So that is our base case. Okay. And yeah, you should remember the base case, because if you don't, then you will end like this. Okay, so let's look at base case now. Okay, so we have the body of factorial function here, and in case of factorial, we reach the base case when n becomes a zero. Okay, we cannot break it any further, and this is why n is equal to 0 is the base case for our factorial function. Okay, in every recursive function that you write, there is going to be a condition till which you can break the problem. After that condition, you cannot break it any further, and that condition is specifically called base case. Okay, so now that we have understood the importance of base case and what is base case, let's have a code demo now. Okay. Okay, let us understand this recursion function. But before we go into that recursion function first, let us understand this Fibonacci sequence. What is Fibonacci sequence? So in Fibonacci sequence, a term is basically the sum of last two terms. Okay, for example, 2. 2 is 1 plus 1, right? If we move on to 3, 3 is 1 plus 2, and 5, 5 is 2 plus 3. So in Fibonacci sequence, basically any nth term is the sum of n minus 1 term plus the term at n minus 2. Okay. Now that we are clear of our understanding of Fibonacci sequence, let us dive into the code here. So I have written a recursive function here that calculates the nth term at Fibonacci sequence, and the base case for this function is n is less than or equal to 1. So whenever we will have n is less than or equal to 1, we are going to reach the base case for Fibonacci, and we will just return the n. Let us see it by an example. Suppose I wanted to find the second term of Fibonacci, right? So I'll go in the else block and I'll say that return to me the sum of Fibonacci 1 and Fibonacci 0, right? Fibonacci 1 is essentially going to be 1 and Fibonacci 0 is going to be 0. So the second term of our Fibonacci sequence is going to be 1. We have declared a variable n which is equal to 6, and we are essentially going to print the Fibonacci sequence term at index 6. So let us go and run this program now. And if we come to see the output of this function, we can see that the Fibonacci term at index 6 is 8, which we can verify in the Fibonacci sequence that 8 is the sum of 5 plus 3. So yeah, that will wrap up the code demo for now. With the code demo being done, this video will end here. So thank you for your time, guys, and I'll really appreciate it if you can subscribe as well, so that I can make much more videos like this. And yeah, I'll see you in the next one.